Sorted array, you are given two integer arrays nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements nums1 and nums2 respectively. So you can see in the example they have given nums1 array and nums2 array with m as 3 and n as 3. M is the number of elements presenting in nums1 and n is the number of elements which are presenting in nums2. Merge nums1 and nums2 into single arrays sorted in decreasing order. So the question is asking us to merge these two arrays, nums1 and nums2. So simple, before going on to the next passage, I just wanted to show you what they are asking for. So nums1, they have given 1, 2, 3, and nums2, they have given 2, 5, 6. So we will take the 0 later, but just see what they wanted. They just want to merge these two arrays in a sorted format. So usually in layman's term or in brute force approach, we can create a temp array, a new temp array, and just compare this value versus this value, and whichever is smaller we can add to our temporary array list. One is less than two, yes, so add one. Is two and two both are same, so I'm adding the same. Three and five, 3 will be added, and then whatever the pending 5 and 6. So we get this temporary array, and this is the answer which they wanted. So actually easily we can solve it by creating a new temp array, so which causes a time complexity O of n and space also O of n, but they don't want us to do in this fashion. So let's go and see what how they want it. If you see the last passage, they say the final sorted array should not be written by function but instead stored inside array of nums1. So they want us to do this not in a new array but in place, that is in nums1 array itself. They want us to merge it in nums1 array itself. Now, next thing they have given to accommodate this, they have given one help, because they are asking, they are demanding that we want in nums1. So they have given one help. What is that? To accommodate this, nums1 has length of m plus n. Now, if you see, they have given the length. This is actually m, but they have added this triple zero so that we can include this next nums2 into this array. That's the reason they have given the entire length of nums1 as m plus n. The entire length of nums1 is m plus n, and length of nums2 is n. Where the first m elements denote the elements that should be merged and the last n elements are set to 0, which should be ignored. So first elements are m and another last three elements are 0, which are n, and this is nothing but to accommodate nums2 into nums1. So how are we going to do it? First thing, we understood we cannot create a new temp array. Now the simple way to do this sum is, you have this array, right? 1 2 3 triple zero, right? And then you have 2 5 6, right? Now what you have to do is, simple, in simple format, to solve this simple sum we can easily do it. We just add this nums2 into nums1. So our array becomes 1 2 3 2 5 6. So this is not a new array. Okay, let me just, this is not a new array. This is in place in nums1. I'm just going to insert 2 5 6. So we got this. This is a nums1 array. This is nums1 array, and then we have to sort this nums1 array. So after sorting we get something like this: 1 2 2 3 5 6. We get this sorted format. After sorting we get this array. So in place we just added nums2 in nums1 after m position, that is, this is the m position, right? These are the m elements. After m elements, if I'm adding the n elements of nums2, then I'm getting 1 2 3 2 5 6, and this array I'm sorting it over here, which gives us an answer. And this is the time complexity of O of log n, which is a, again, we can optimize this solution. This can be acceptable, but this is log n solution. We can do an optimization in this solution. Let's see what is our optimized approach for this particular sum. First of all, this optimized solution consists of three pointers. I will first let you know the position of this pointer, which is very important. So we have the nums1 array as 1, 2, 3, then triple zero, and nums2 array as 2, 5, 6. So let's see what are those pointers. We have R1 pointer, which is at the end of M, which is at the end of M. We have R2 pointer, which is at the end of N. And we have W1 pointer, which is called as a writer pointer, which will write it. This is R1, reader 1, reader 2, that is R2. And W1 is at the last position of M plus N. It is at the last position of M plus N. That means, how can we denote this into the code? That also I'll tell you. R1 is actually at the position, R1 is actually at the position of M minus 1. Why M minus 1? Because indexing start from 0, 1, 2, right? So we are giving R1 is at the last position. That means in the code we have to write R1 is at M minus 1 position. Same thing, R2 is at the last position. That means it is in the code we will write as n minus 1 because the indexing start from 0. Same thing for W1. W1 will be at the position of m plus n, which is the total length of nums1, and we are doing minus 1 because of indexing purpose. So W1 is at the position of m plus n minus 1. These are the positioning of the pointers. So let me repeat, there are three pointers, R1, R2 and W1. All these pointers are at the last of their arrays. R1 is at the last of M, R2 is at the last of N, and W1 is at the last of M plus N minus 1. Let's start the approach. This is just the positioning. Now, let me show you the approach. It's a very simple approach. If you, I have tried my level best to explain it. Let's see how it is. Okay, so we have R1 and we have R2 and we have W1. Now there is a simple formula over here. We are checking is if R1 is greater than R2, then we are going to, if this is the case, then we are going to shift R1. If this is not the case, then we are going to shift R2. Let me tell you. Let's see, R1 is 3 and R2 is 6. So is 3 greater than 6? No, 3 is not greater than 6. That's the reason we are taking the 6 and shifting it to W1. We are shifting it to W1. So 6 is shifted over here and we are removing this R2. The work is done. We are removing this R2. Now R2 is shifted over here at 5, number 5. And at the same time, W1 is shifted from the last index to the next index. This is the W1. So basically W1 is traversing backwards, R2 is traversing backwards, and R1 also will traverse backwards. We completed the first number, that is the 6 from nums2. We shifted it to nums1. Good that we did that with the help of this particular formula, that is R1 greater than R2. Next again we'll see. Next we'll see our now R2 is shifted to 5, right? Our R2 is shifted to 5. So now let's check, is R1, that is 3, greater than 5? Is 3 greater than 5? No, 3 is not greater than 5. That's the reason we are shifting our 5 towards W1. That's it's the, if the answer is no, right, we are inserting nums2 into nums1. Simple. So this is what I'm doing it. I am shifting the nums2 to W1 and I am deleting this number. This is done. We are done with it. We are completed. So now the W1 will be again shifted to back because we have processed that. Now W1 is over here. Let's see again. Let's see again. Uh, Now see, here is the catch, okay? Is R1 greater than R2? What is R1? We have 3. We have 3 as R1. Is 3 greater than 2? What is R2? It is 2, right? Let me just write this. Is 3 greater than 2? And see, R2 is coming back, right? It is shifted because we process 5 and 6. So R2 is over here. Now we have to ask the same question. Is R1 greater than R2? Yes, this time it is yes. This time it is as yes. So what we are going to do? We are not going to shift R2. We are going to shift R1 to W1. So what will happen is we are going to shift R1 value to W1, and now here becomes an empty box, right? And now W1, this is process, right? This is process. So W1 will be shifted towards backwards. So now the W1 will be shifting over here, and R1 will be shifting again towards back. Are you guys with me? Yes, R1 is shifting towards back. Now you see W1 has an empty box. Let's again do the formula. Is R1 greater than R2? What is R1? 2, and R2 is also 2. So both are same. That's the reason I will be shifting same R1 to W1. So now it becomes this way, and R2 gets a passage. R R1 gets a passage. So this is a blank space which R1 gets because we just shifted this 2 over here because it is same, right? It's not greater, it is same. So it doesn't matter. We just shifted over here. Now what will happen to R2? R1 we have done, we have completed. So R1 will go towards back. So R1 now will be going over here at the first position. Still we have R2. Still we have R2. So what we are going to ask the same question. Is R1 greater than R2? No, R1 is not greater than R2. 1 is not greater than 2. That's the reason we are shifting R2 towards the W1. Here this W1 is also shifting here, okay? So now we are entering this R2 value to W1 again, and 1 remains as it is because this is exhausted. We are completed. So 1 remains as it is. And thus we did entire solution in nums1 array in place by just traversing backwards and checking the max value. By just traversing backwards and checking the max value. The catch was in this position. I can show you once again. Exactly what I've done is 1, 2, 3, and this is 000, and this is 256. In short, I will show you. This is R2, this is R1, and this is W1. Simply, I am saying if R1 is greater than R2, that is, if 3 is greater than 6, if 3 is greater than 6, then if this is not the case, this is not true, right? 3 is not greater than 6, this is not true. So that's the reason I'm shifting 6 towards the W1. That means this 0 becomes 6, and now W1 is shifted towards back, and my R2, I have processed 6, so my R2 becomes 5. Again ask this question, is 3 greater than 5? Is R1 greater than R2? No, that's the reason I am shifting again R2 towards W1, and I'm shifting over here. My R2 is processed now. This is processed, so I will be shifting R2 over here, and W1 will be again shifted. W1 will be again shifted backwards, right? W1 will be again shifted towards backwards. Once it is shifted towards backwards, again same question, here is the cache. 3 is 3 greater than 2? Is R1 greater than R2? Yes, here 3 is greater. That's the reason I'm shifting R1 to W1. In this case, I'm going to shift R1 to W1. So this will become 3. Here there will be a blank space. R1 will be towards the back. it will shift towards back, and at the same time w1 will be shifted towards back. Now again ask r1 greater than r2. No, it is same, so we can put 2 over here, and this is done, right? This is done. So r1 is also done and w1 is also done. We have processed. So again here it becomes a blank space. R1 comes over backward, and at the back blank space we get the W1. Again ask, is R1 greater than R2? Yes. Sorry, it's not greater than R2. So we are shifting our R2 over here in this direction, and R2 comes over here. This is got exhausted. We have completed nums2, and that's the reason now there is nothing to compare, and we can return this as an array. They haven't told us to return, but in place we did this solution, and the time complexity is O of n plus m, because n is the length of the second array and m is the length of the first array. So total it is O of n plus m. Space is also O of n plus m. There is nothing. Space is O of 1. Sorry, space is O of 1 because we are doing in we are not using extra space like an area or something. So this is it, and let's start coding. Coding is also very simple. We just don't have to return anything. So merge sorted array, and we have int of nums1. Then they have given int of nums2. These are the two arrays. Then they have given the length int m and int n. And we have to define three pointers, that is r1, which is at m minus 1, and r2, which is at n minus 1. Now for int of w1, we have not defined what is our w1. M plus n minus 1, and then we have w1 greater than equal to 0 and w1 minus minus. Now what we have to check? First thing first, we have to check if r1 is greater than equal to 0, and also r2 greater than equal to 0. If this is true, then only we are going to check ahead. And what we are going to check, very carefully check this line. Here we are going to have nums1 w1. What will be nums1 w1? If nums1 r1 is greater than nums2 r2, if this is greater, then nums1 r1 minus minus, or else nums2 r2 minus minus. Simple. This is the one liner which explains everything. If this is greater, if this is greater, this is true, then put r1 minus minus minus. If this is not greater, which was always happening, and that's why we were putting r2, and we at the same time we are shifting r2 backwards. And last case, this I have to explain you. This is like if r1 greater than equal to r0, then what we are going to do, and if r2 greater than equal to 0, what we are going to do. These are the exceptional cases. What are these cases? I'll tell you in a minute. So these are the two last exceptional cases. What are this? If r1 greater than 0, that means there is no r2. See, we are out of r2 right here. In the diagram, I showed you that there is no r2 at all. Then in that case, we are just using r1 in our value. We are not comparing, we are using r1. So that is the exception case which I'm writing over here. So then in that case, nums1 w1 will be same r1, nums1 r1 minus minus. And same thing, same as it is, if there is no r1 at all, then we are just going to include r2 over there. That's it for the code. And the time complexity, I said O of m plus n, and this is the way we can solve it, and I made it more easier to explain. But if there are any issues, you can let me know. Thank you for watching.